Well, hey, Piotr, thank you so much for being willing to chat for a little bit. My name is John Hammond. I'm honored to be hanging out with all of you at Halborn here. Finally get to meet you in person, which is super exciting. But do you mind, just for, I guess, my own understanding, to get me in on the loop, who are you? What are you up to? What are you doing at Halborn? What do you focus on, etc.? The floor is yours, my friend.
Thanks, John. Thanks for having me. I'm absolutely delighted to be here and having a chat with you. So, my name is Piotr. I'm the Solana practice manager at Halborn. So what that means, I'm an auditor and I manage the Solana team. Consists of several engineers, and we're focused on smart contract, which in Solana are called program audits, white box audits to that. And what we also do is we develop and come up with tools that can both help our work internally and make the community more secure and kind of unravel the mystery of smart contract and blockchain security in general.
I love it because I come from the traditional, quote unquote, and I put that in air quotes, traditional cybersecurity with malware and hackers and Active Directory and all that shenanigans, right? But the whole Web3 or blockchain world is completely new to me. So I'll be totally upfront and honest with that. So Solana, right? If that's your bread and butter, is it totally cool? Would you mind giving me just, hey, how do you tell people what Solana is, what it is that you do in your own words, like in your own definition, what is Solana and how does that come to life in Web3 and blockchain?
Yeah, absolutely. So I'm just gonna base whatever I'm going to say now on the Solana white paper, because it gives like the most detailed description of the thing. So Solana claims to be the first scalable proof of stake blockchain. Now, what that means is it can scale with the number of participating nodes, which are called validators. Intuitively, you might think the more people use it, the better it is, the faster it is, the more performant it is, which is not really the case because it's a decentralized system, so all the nodes have to talk to each other. And when I'm talking to you, this is a direct conversation, but if we were to talk to 1,000 people in this room and just introduce ourselves, it would take us the better part of the morning to do that.
Oh yeah.
So Solana is trying to solve this problem by introducing several key innovations that drive the performance way above anything that we have now. So the Solana white paper argues that the network is capable of processing 700,000 transactions per second on a 1 gigabit network. Now, just to put it in some sort of context, Bitcoin does 5 transactions per second. Wow. Ethereum does like 15 on average. And Visa, which is the most performant centralized system, so much easier to manage and arguably much easier to implement because centralized systems has been with us for close to 50 years now, can process up to 24,000 transactions per second. It doesn't like on a daily basis, but it's capable of doing that. So if you compare the most performant centralized system with 24K and then you have Solana with 700K, and this is a limit that as technology develops, as networks get even more faster, more performant, and hardware gets better, because that's another thing that Solana scales with. So as hardware gets better, so does Solana. So it's 700K, and it's capable of doing it now. But who knows what's gonna happen in 5 years or a bit further down the road. So I think it solves a really big problem that troubles many of the blockchains that we know now.
That's awesome. It's something that I feel like I probably have played with a little bit more so than any of the others, just because, hey, that transaction speed is fantastic. I believe gas fees, is that right? They're practically minimal for just being able to play, just being able to hey, let a newcomer understand and try to tinker with this. what does that look like to you? Is that on the command line, hey, mint in tokens? Is that carved through Rust? Is that carved through Solidity? Or is that strictly a different one? What, I guess, languages and tooling and tool chains allow you to really do what you do for your day job in Solana?
So like Solana initially was written in C because like Solana is trying to be a decentralized operating systems, and like most operating systems are written in a low level language, C for example. But then they made a transition to Rust because Rust is a memory safe language, and memory related attacks are a big thing in C if you don't do it right. And Rust is, by definition, secure from that. And unless you explicitly write code that's in a block that's literally titled unsafe, you're not gonna end up having memory corruption issues. So the whole blockchain is written in Rust. You can write smart contracts, which are just pieces of software that run on blockchain. You can also write them in Rust. You can also write them in C, because what they are translated to, what is actually being executed, is something that's called BPF, which is an abbreviation for Berkeley Packet Filter. And this was originally created as a technology that as a language, that's basically assembly that's executed in Linux kernel. So you don't want to execute untrusted or malicious stuff in your kernel. You want to, because it's the highest privilege you have in Linux. So you want to make it as performant and as secure as it is. So Solana trying to be a decentralized operating system. Also, learn the lesson from Linux and how to handle BPF. So you can compile C to BPF. You can compile Rust to BPF. So Solana has their own BPF toolchain that is used in compile time to translate the high level language. Like, that's a funny distinction, because like you translate high level language to low level language, but then Rust is also like low level compared to Python or say JavaScript. So but on principle, like if it's human readable and it's not like just random bytes, you call it high level. So it translates high level language to low level language that understandable by machines, which BPF technically is. Now the CL, so Solana tools, Solana CLI, that's extremely user friendly. They have a full suite of tools for basically any sort of application you need. So you can mint tokens, you can check the balance of your account, you can query the chain to get any sort of data that exists on chain. You can get it via the CLI. Now you might need some extra steps after you get the data to understand it, because ultimately it's just bytes. So you have to translate it to whatever you're expecting. So even like Solana CLI is great, but there are some extra steps that you have to take yourself in order to understand what the chain is telling you, because it's always gonna tell you the truth. You just have to know how to understand this truth. So just a few more words about the CLI. So it's just as easy as running a bash script to download the whole CLI suite, and it consists of literally hundreds of commands, which are also extremely performant, because one, they're written in Rust, and two, they're using Solana, which claims to be the most performant blockchain in the world. So it's like all about speed. And gas fees that you mentioned play really nicely into this narrative, because like if you think of 700 transactions per second, 700,000 transactions per second, like if a transaction costs $1, it's a lot of money moving around. So Solana, because of all these optimizations and innovations, they managed somehow to decrease the fees to like basically peanuts, so that they actually pretty much free, to be honest. So one thing that is a consequence of that is that many NFT projects migrated, or they're building on Solana rather than say Ethereum, because of the gas fees, which are practically non-existent on the chain, whereas it's like the biggest deal breaker in Solidity, because you need some investment up front to make it work, and either as a creator or as a user, you end up paying quite say relatively a lot to the miners, whereas in Solana there is a very, very, very little upfront cost, but as you're using it, you stop noticing it.
That's so interesting to me, because again, I hear you go. You mentioned, hey, obviously that command line interface is extremely friendly, but at its core, this is the low level thing. Like Rust, it's boiling itself down to Berkeley packet filters, like a hardcore assembled operating system, decentralized stuff. It's very, very cool to hear about that duality in my mind. I'm curious what you as an auditor, right, tend to look for. Obviously, offensive security engineer, obviously trying to hack and trying to find the flaws and the weaknesses and the misconfigurations in what is kind of proposed to be, right, hey, some very secure thing. What is it that you might be hunting down? If it's a vulnerability, or if it's a weakness, if it's a flaw, what are the things that your eyes light up when you find it? If I may ask, is there any road to drive down with that one?
I guess I'll try and explain it on an example that we all know. So basic web application. So like imagine you have a web application that is sitting on a Linux server, say Apache. You know that if you have an Apache, unless you're unless you don't want to, unless you're a really alternative guy, you're gonna go for Linux. So if you see Apache, it's probably gonna sit on Linux. So this application doesn't mean what it does. It processes some data, so it has some business logic implement. It might not even have to be business. It does not have to make any money, but like any logic that's implemented, it's called business logic because it's like serve some purpose. So if you're trying to so say it's a white box audit, so you have access to the source code because we do, because like blockchain on principle is a public thing. Everybody can participate with equal rights, so it only makes sense to provide source, among multiple other reasons, to provide the source code to the auditors. So say you have access to the source code of the web application, and there are like to me there are like three main categories of vulnerabilities I would look for. So the first one is obviously business logic. Is there like a flow that you can break, or are there any steps in the processing that you can bypass? You can take like a shorter path rather than going the happy way. So that's one. The other is this web application. It is written in some language, whether it is JavaScript, Rust, PHP. Like we all know, languages have their differences. And what it implies, there are different vulnerabilities that stem solely from the fact that a web application is written in this language and not the other. Say in C, we know that we have to be really careful with handling memory and buffers and things and overflows, really low level stuff, which it's not going to be the case in, say, Python, because Python abstracts all that, low-level magic for you. So you don't have to worry about that. But there are, say, if you're using Flask, there are some, serialization issues. So which is not going to be an issue in C because there is no Flask in C. So that's something that's specific to Python, but not to C. So there's this language vulnerability class. And the third one is, because the web server is sitting on some sort of operating system, it most likely interacts with the system in some way, whether it is OS or file system kind of interaction. So if a web application is creating files, you're gonna you want to try and abuse this flow. If you can create a file that's too big, or you can request a file that you should not have access to, or you can delete a resource. And this works differently on OpenBSD. The interaction is somewhat different on Linux, on Windows, on Mac OS. So this is the third class of vulnerabilities you have to look for. And as blockchain is also I believe has those three classes of vulnerabilities. That's what I am looking for. So if I have an exchange DApp, which is a decentralized application, I will be looking for errors in business code. I will be on business logic. I'll be looking for errors in how the protocol, the blockchain features are used. So I'll also be looking at language specific vulnerabilities. If it's Rust or Solidity, those guys have different types of language specifics to them. So it's like a starting point. Obviously, it's not how to hack an app, because each app is somewhat different than the previous one. There are similarities, and you obviously learn from your previous work, but you always have to understand the protocol to the core to know where the vulnerabilities might be.
That's cool. I would think the severity of the flaw, what the impact that could come, probably increases as you get lower and lower in those three tiers that you just kind of gave me, right? Hey, obviously an operating system low-level thing is probably going to be more dangerous than an authentication bypass or quote-unquote for a business logic thing, right? Has there been some earth-shattering, crazy shenanigans, big incident like that? I might be naive here, but I think, we saw the Solana network kind of go down. Is that fair to say? What's shaken up, if there is something going on?
So I guess it was just a couple of days ago.
Right.
So, Solana went offline. The whole network halted for several hours, and that was due to minting bot. So an NFT project got really popular in the community. So someone just wrote a bot that kept spamming the network with transactions.
Wow.
And I mentioned that Solana theoretically can handle 700k TPS, but it was supposed to, the bot expected it to handle 4 million TPS, a number that's inconceivable even in centralized system. Maybe in CERN in Geneva they do that, but I don't really believe most web servers can handle this sort of traffic. So that's what brought it down. So Solana advertises its mainnet, because that's also the thing about blockchains. They always have several instances of the network. So you have the mainnet, so the production environment. You have development environment. You have testnet, which is just for testing, and those may vary between each other in features, because experimental features are first introduced to the testnet, then they make their way to devnet, and then finally, if they are battle tested or the community decides they're battle tested enough, they make their way to the mainnet. So Solana advertises their mainnet as still in beta. So if you've ever worked with anything in a beta version of anything, it's bound to have bugs and
right.
All different kinds of stuff that is unexpected may happen. So I think that's what's happening. A thing that we have to keep in mind is that Solana is a really new thing, and it came to life I think in 2020. So it's, to be honest, a little over a year old now, and the first Solana conference was last year in November. So it's still in infancy, and I hope that all the issues that that trouble it will be resolved as they are discovered, because like this is the thing with software. There are so many applications, there are so many ways users can interact with it, and some projects even fail by succeeding, so they get to kind of what I believe happens right now. So Solana failed by succeeding because it attracted so much interest from people from the NFT space, that all those people that previously were on Ethereum, they moved on to Solana. Now the other thing that might have gone wrong is that like the API 101 is rate limiting. So if you run a server, ideally you don't want to accept too much traffic in order for your server not to just burst into flames. So that's one thing that might have been improved, I believe. So like if you have a node and it accepts transactions, you might want to like limit the number of requests you're accepting, because like if it applies in traditional security and traditional server maintenance, I also believe it like in some way it can also be applied and should be applied to blockchain as well, because ultimately it's external data that you have to handle in some way.
So this bot, I remember you mentioning, hey, succeed or fail by succeeding, right? The bot was not some intentioned adversarial threat actor, malicious actor wanting to take it down. It was by the nature of, hey, we had a lot of success with this potential token. Am I understanding that right?
I might be a bit fuzzy on the details.
Okay,
but,
totally no worries.
Yeah, but what I believe is the intention was not malicious. Like it was malicious in a sense that somebody wanted to be first to mint the token. So
fair enough.
So somebody was just smarter than the other people, so they just wanted to take advantage of that and just spam the network with transactions. And I don't know if they managed to mint the NFT. They managed to bring the network down, which is an achievement of sorts, but I don't really know if that's the outcome they were hoping for.
Gotcha. Are things like that some things that are, in your mind, seem almost trivial or still complex? Or I know, as you mentioned, hey, we're still ironing out the kinks. Is that like a break-fix mentality, or is there a very forward-looking, future-focused perspective on like, all right, we need to take security more seriously, or is it just kind of whack-a-mole right now? I realize it's a big, broad philosophy question, but what do you think? Is Solana leading the race in that, or is there still more to do?
So the thing about blockchains is they are really open to community feedback.
Yeah.
So each blockchain has at least one official Discord channel, or any other type of social media platform they're using to communicate and talk to the user. They have their own forum and stuff. They do meetups, they do hackathons. I think the next one is in London. And so they're really open to community feedback, because ultimately they were created by people that were not paid for doing that. Well, the money came after they succeeded, kind of. So Solana, for example, they have this roadmap of features that they are trying to implement, and all those features are discussed by the community. The best example is you can just go on Solana's GitHub and just look at the sheer number of issues and pull requests that are submitted on a daily basis, and the community is actively participating in the discussion. So they really shape how the network is going to look like. And the thing about it is that even though there is a core team that has the contributor and right access to the repository, they still are open to what the community says, because chances are there's going to be someone with a say PhD in embedded systems in the community that really likes Solana, and they feel they can make really good impact on how the chain is going to look like. So this is I believe the beauty of decentralized public systems, that everybody, I mean yourself, myself, we can participate in how the future is going to look like.
That's very cool. I really like that idea. Hey, it's something that we can all be a part of. And I think it's fulfilling to see it come to life. And I think it's even more fulfilling when we see the successes of, hey, there was an issue, there was a flaw, but we fixed it. And now we're looking better for the future and improving the security posture. So super cool. Thank you so much, Piotr. This has been awesome. I feel like I've learned something. I hope anyone listening in might have just felt the same. But thank you for giving me a slice of life on what you're up to at work at Halborn and what Solana is all about. So thanks again.
Thank you, John.